So in this problem, we have a person standing here, and this person is shooting up a laser at this point, and it reaches down here. What we want to find is what is the distance from here to all the way here. So the first step is we're just going to try to find some values, that we can already find using basic principles like Pythagorean theorem. Here I can set this sort of Pythagorean theorem here. You have a right triangle, you have a right angle. So let's try to find this guy, and then we can try to find this guy over here. So I actually have a program in my calculator that'll help me find the Pythagorean theorem. So but I am going to do it out just for this problem's sake, and then we can erase it later. So this is going to be, we can denote this as A, we can denote this as B, we can denote this as C. So we have A squared plus B squared equals C squared, and we're trying to find B because we already know C, so we can just plug in the values. 1.7 squared plus B squared equals 8.1 squared. 1.7 squared is just going to be 2.89, which I'll round to 2.9, plus B squared equals 8.1 squared is just going to be 65.6, and then you subtract B squared, you subtract both of these, and you will get 65.6 minus 2.9, which will give you 62.7. You square, that looks like 1, you squared that 62.7, and you will get B equaling 7.91. So that is what our side is equal to. I just erased all of the Pythagorean theorem work problems so that we have more space to do this problem. The next thing that we're going to do is we're going to try to find this guy over here. What the heck is this distance? I mean, we already know from here to here, so we really have to find this small increment. To do that, we're going to use a little bit more trigonometry, a bit advanced trigonometry. So first up, let's go ahead and try to extend this line. I want to extend this line a bit. You'll see why in a second later. But to extend this line, we notice how I'm going to have an angle over here, and then I'm going to have an angle down here, right? And then we can redraw our triangle. We already know, the length and everything. This becomes 8.1, this becomes 7.91, and then this becomes 1.7, and we have something that looks like this, and we can even draw our right triangle. So we can label this as theta 1, and this will be theta 2. And what we're trying to find is theta 2, so we can find this guy over here. It's just some basic trigonometry that we're doing. Now these are in a straight line, but they're not transverse, because you see this line is kind of going, it's not going this way, it literally goes there. So we're going to do something else. So what I'm going to do is I'm going to find the sine of theta 1. We'll get 7.91 divided by 8.1, which will give 0.98. We'll round that. It's actually 0.96, but we're just going to round that. And then I'm going to take the inverse of that, 0.98, and I get 78 degrees. I'm actually going to take the full number. And I get something 77.56, so we'll say 77.6 degrees. There's also another way you can get that angle, theta 1. So first what you can do is you can try solving for this angle over here, and then we know this guy makes a 90-degree angle, so you just subtract 90 degrees by this angle, and then you'll get 77.6 degrees. But that's a bit too much. If we just can find the cosine, then that's probably going to be way better. Oopsies. So that's why I did this way. But we can also do that other way. Alright, so the next step is finding theta 2. Now I'm going to use Snell's law. We're not going to use any more trigonometry now. We're going to use something called Snell's law. After all, we are shooting a laser beam. This title of the video is called Snell's law, so let's use it now. So the Snell's law is going to be N1 sine theta 1 is equal to N2 sine theta 2. It's a bit big, but that's why. This is called Snell's law. And N1 is basically the incidence angle, and N2 is the refraction angle. So in this, we're just going to use, once again, we have theta 1. We're going to put that into theta 1, and this over here is air, and this over here is water. So we can substitute the values of N1 and N2 of air and water. Alright, so I wrote out I substituted the values and we got this equation. And guess what? We can actually solve for sine theta 2. And when we solve for it, we get this angle. So that's awesome. Let's go ahead and do that. So I'm going to do sine theta 2 is equal to 1.00029 times sine of 77 degrees over 1.33. And if you do the math, it should equal to 0.73. So then we take the inverse of that. So the inverse of that is going to give you 47 degrees. So I just put this in my calculator if you're wondering, so you can go ahead and do it in the calculator or by manually as well. So let's go ahead and write what we know. We know theta 2 is going to be 47 degrees. And now we can go ahead and we have to think, okay, how am I going to get this guy over here? How am I going to get this bit? Let's think of our three trigonometry functions. We have sine, we have cosine, and then we have tan. And what we're trying to do is we're trying to find this guy over here. That's what we're concerned about. So we know that sine is opposite over hypotenuse, right? And we know cosine is adjacent over hypotenuse. And then we know that tangent is TOA, so that's opposite over adjacent, right? With that out of the way, what do we know about this triangle? We know that this side over here is 3 meters, right? And we know our angle that we should worry about is theta 2. That's the only angle we know. Now we can take other angles like this guy and we can have a right triangle, but that's again, when we know theta 2, why do we need to do any more subtracting and addition? It's going to give you the same result. So let's try to do the least work. So we have theta 2 equals 47 degrees, and we have 3 meters. So we want to try to find this. Let's use sine. So let's do sine first. Let's see how it looks like with sine. So we have opposite over hypotenuse, and the opposite is going to be this guy and this guy. And if we multiply it by 3 meters, it's going to give us, well, 3 meters is adjacent. So will that give us opposite? No, that won't really give us opposite. It'll just give us adjacent times opposite over hypotenuse. So sine theta is just not working. How about cosine? Let's look at cosine. It's adjacent over hypotenuse, right? If we multiply 3 meters, which is adjacent, it'll just give us adjacent squared times hypotenuse, which is not what we want. Now let's look at tangent, right? We have opposite over adjacent, and if we multiply adjacent by that, the adjacent cancels out, and it gives us opposite. And guess what? We want the opposite. This side over here is the opposite of theta 2. Alright, it's the farthest away. So with that out of the way, this side is going to be equal to 3 times tangent of 47 degrees. Remember, 3 was the adjacent that we were talking about earlier. The adjacent times opposite over adjacent, and the adjacent cancels out. That was 3. So now let's go ahead and solve 3 tan 47, which should equal to 3.22. So this guy over here is 3.22. And now we can actually find this entire distance. So we know from here to here it's going to be 7.91, and then from here to here it's going to be 3.22. So it's just basic addition. We'll add this with 7.91, and that is going to give us 11.12 meters. This entire distance here is going to be, let me actually use yellow to mark that. This entire distance is going to be 11.12 meters. And look at that, we just found our answer using some trigonometry and Snell's law.